One of the most widely used techniques of integration is the integration by parts. And this technique is taken from the formula for the derivative of two functions. Say, if we let u and v be functions differentiable in x, then the derivative of uv in terms of x is equal to u dv plus v du. And if we integrate each term on this equation, then we have the integral of the derivative of uv is equal to the integral of u dv plus the integral of v du. And we all know that the integral of the derivative of a function is equal to the function. So we have the integral of the derivative of uv is uv, which is equal to the integral of u dv plus the integral of v du. Now, if your integrand contains two parts, the u part and the dv part, then you have the integral of u dv equals uv minus the integral of v du. And this equation is taken from equation 3 by transposing this term on the other side of the equation and leading you with the integration by parts formula. Again, that's equal to the integral of u dv equals uv minus the integral of v du, where u is something easy to differentiate and your dv will be something easy to integrate. And from your u, you differentiate your u, you have your du, and then you integrate dv, you have your v. Now, if you might ask, what's the best way to identify your u? Okay, so is there any guide or technique on how to easily identify which will be your u part? So for that purpose, you can use this acronym. It stands for logarithmic, inverse, algebraic, trigonometric, hyperbolic, and exponential function. And that is abbreviated as LIATE. Again, that's LIATE. So whichever comes first on the hierarchy, then that will be your u. So for an instance, if your integrand contains a logarithmic function and an algebraic functions, then your u will be your logarithmic functions and your dv part will be an algebraic function. So we have some example here. Say we wish to integrate the product of x cubed e to the x dx. Okay, from our acronym, again, so we have e to the x times x cubed, where x cubed is an algebraic function and e to the x is an exponential function. From the hierarchy, so we have algebraic function comes first before the exponential. So we will let u be equal to x cubed and your dv will be e to the x dx. So differentiating x cubed, you have du equals 3x squared dx. And then integrating dv, you have v, and then integrating e to the x dx is simply e to the x. And then again, do not add c for this purpose because we will now apply it to the formula. Okay, so you have v, so that's x cubed e to the x minus the integral of v du. You just multiply these two, then you have 3x squared e to the x, then you affix dx. So you notice on the integral part, you still have a product of x squared e to the x dx. So again, for the second time around, you will let u be equal to x squared, and then dv is against e to the x dx. So again, you differentiate, you have 2x dx, and then integrate, you have e to the x, and then you copy the first part, x cubed e to the x minus 3 times, and then you apply the uv minus the integral of v du formula. So you have uv, that's x squared e to the x minus the integral of v du. Again, multiplying these two, you have 2x e to the x dx. And then once more, the integral part still contains a product of x and e to the x. And then for the third time, you can let u be equal to x, and dv is still e to the x dx. And then differentiating u, you have dx. And then integrating dv, you have v. And then integrating e to the x dx, you still have e to the x. And then you have x cubed e to the x minus Then you just introduce 3 each term inside here. We have negative 3 x squared e to the x. Negative 3 times negative 2 will become positive 6. And then for this part of the integral, you apply the UV minus the integral of v du formula. So again, that's UV x e to the x minus the integral of v du. v du. So what you notice on the last part of the procedure is that the integral part only contains e to the x dx, which can now be integrated by basic integration formulas for exponential functions. So finally, we have x cubed e to the x minus 3x squared e to the x plus introduce 6 each term here, 6x e to the x minus 6, and then you integrate e to the x dx, you'll have e to the x, and finally you can now add c. So we have the integral of x cubed e to the x equals x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 e to the x plus c. Okay? Another technique for this techniques of integration is what we call the tabular integration by parts. So in this case, we will have two columns, the u part and the dv part again. So for the column u, we choose a function that is something easy to differentiate, and for the column dv, that is a function that is something easy to integrate. So for our first example, that's x cubed e to the x, we'll let u be equal to x cubed following the LIATE acronym, and then your dv part will be e to the x. So what comes next is you keep on differentiating your u part until you reach where the derivative is equal to 0. So we have 3x squared, and then you continue differentiating. So 3x squared, the derivative will be 6x, and then derivative of 6x is 6, and then the derivative of 6 is 0, and that is where you will stop differentiating. And then for the dv part, you keep on integrating until you reach the row where the derivative of u is equal to 0. So the integral of e to the x is simply e to the x. Then the integral of e to the x is e to the x. Nothing happens. E to the x, e to the x. And then for the distribution of sign, you start at positive and then it goes alternatingly. So that will become positive, negative, positive, negative, positive. And then you do the slant multiplication. So we have x cubed times e to the x equals. So that's positive x cubed times e to the x. That's x cubed e to the x. And then negative 3x squared times e to the x. Okay, here it goes. And then for the last part, you do the horizontal multiplication. So we have, again, positive x cubed e to the x. That's x cubed e to the x. Negative 3x squared times e to the x, and then plus 6x e to the x plus 6x e to the x, then minus 6 e to the x minus 6 e to the x, and for the last part, that's positive 0 times e to the x, that is 0, and then that's the time where you will integrate. And we all know that 0 times a function e to the x is 0, and the integral of 0 is a constant c. So this is taken by using the tabular integration by parts. So if we want to compare our answers, so this is done by using the long method, and this is done by using the tabular integration by parts formula. So we have x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 e to the x plus c. And we already see that the answers are similar. Okay, let's have some more. So this time we take the case of an algebraic function and a trigonometric function of the form sine x. So according to the acronym, that's LIATE. So the algebraic function comes first before the trigonometric function. So in this case, we have u equals x cubed, and dv is sine x dx. And then we just continue the procedure. So we keep on applying the formula until the integral part will be a single function only. So we have du is 3x squared dx, and the integral of dv is v, and then the integral of sine x is negative cosine x. Then again, sorry for that, we do not add c anymore. So we have uv negative x cubed cosine x minus the integral of v du. So we just multiply these two, you'll have negative 3x squared cosine x, and this is negative, so that will become positive 3x squared cosine x, and then you affix dx. Again, for the second time, we notice that the integral part still contains x squared and cosine x. So we take again u equals x squared, and dv is cosine x dx. Again, you differentiate, u is du, then 2x dx, and then you integrate dv, that's v, and then the integral of cosine x dx is positive sine x. And then again, we apply the formula, copy negative x cubed cosine x plus 3 times uv, that's x squared sine x, minus the integral of v du, so that's 2x sine x, then you affix dx. And then the only thing left is to introduce 3, and then you notice the integral part still contains a product of x and sine x. So for the third time, we will let u be equal to x, and du is dx, and then dv is your sine x dx, and then integrating, you have v, which is equal to negative cosine x. So we have negative x cubed cosine x plus, introduce 3 each term here, so you have 3x squared sine x, then 3 times negative 2 is negative 6, and then again, you apply the uv minus the integral of v du formula. You have uv negative x cosine x uv minus the integral of v du. So this is negative, so this will become positive, and then cosine x, and then affix dx. So finally, the integral part only contains cosine x, which is integrable by basic integration formulas for the trigonometric function, specifically for the cosine function. So finally, we have negative x cubed cosine x plus 3x squared sine x minus 6 negative x, so that will become positive 6x cosine x negative 6, and then the integral of cosine is positive sine x, and then you can now add c. Okay, once more, we will try to apply the tabular integration by parts procedure for x cubed sine x. Again, we divide this into two, the u part and the dv part. For the u part, so we have x cubed, and for the dv part, you have sine x. And then again, you keep on differentiating x cubed until you reach where the derivative starts to become 0. So you have 3x squared, then keep on differentiating, that will become 6x, differentiated again, that will become 6, differentiated again, will become 0. And then for sine x, you keep on integrating until you reach this column where the derivative of x cubed is 0. So you have integral of sine x is negative cosine x. The integral of negative cosine x is negative sine x, and the integral of negative sine x is positive cosine x, and the integral of cosine x is positive sine x. And then for the distribution of sine, we have positive, negative, positive, negative, positive, and then you do the slant multiplication. And then for the last part will be the product of 0 and sine x. So finally, we have positive x cubed times negative cosine x is negative x cubed cosine of x. And then we continue. Negative 3x squared times negative, so that will become positive 3x squared, then sine x. And then positive 6x times cosine x is positive 6x cosine x. And then we continue. Negative 6 times sine x is negative 6 sine x. And then you have 0 times sine x is 0. Then integral of 0, you can now add the constancy. So we try to compare. So this is obtained by using the long method. And this one is obtained by using the tabular integration by parts procedure. So we have negative x cubed cosine x plus 3x squared sine x plus 6x cosine x minus 6 sine x plus c, of course. Okay, let's have another one. So this time we take the case of product of an exponential function and the trigonometric function of the form e to the x sine 2x. So for this part, we all know that both exponential and trigonometric functions are transcendental functions. So we take the case wherein you can let u be any of these two. So for the purpose of following the acronym LIA-T, so the trigonometric function appears before the exponential. So we try to follow that rule. But then again, you can just let u be any of these two. So let u be equal to sine 2x and then dv equals e to the x dx. So differentiating sine 2x, we'll have 2 cosine 2x dx, and then integrating e to the x dx is e to the x, and then we have integral of e to the x sine 2x dx is equal to uv e to the x sine 2x minus the integral of v du, and then you just throw outside the 2, and then e to the x times cosine 2x, e to the x times cosine 2x, then you affix dx. Again, the integral part contains product of an exponential function and trigonometric function of the form e to the x times cosine 2x. So again, for the second time around, we apply the integration by parts. So we let u be equal to cosine 2x, basically because on our first substitution, we let u be the trigonometric function sine 2x. And then dv equals e to the x, so we let du is negative 2 sine 2x dx, and v is still, sorry, I forgot the x there, so that's e to the x, and then equals, copy the first term, e to the x sine 2x minus 2 times, you apply the uv minus the integral of v du, uv cosine 2x, that's uv, minus the integral of v du, that is negative 2 sine 2x times e to the x, so that will become positive 2 integral of e to the x sine 2x, and then you affix dx. And then what comes next is you introduce negative 2 each term inside, negative 2 e to the x cosine 2x minus 4 integral of e to the x sine 2x dx. Again, what you notice on the integral part is that the integral part becomes similar to the given function, e to the x sine 2x dx. So, as you can notice, if the integral contains both transcendental functions, never the derivative of u will become 0. So, for that purpose, you're just going to throw this on the other side, leaving you with 4 integral of e to the x sine 2x dx, and then you will add this e to the x plus the integral of e to the x sine 2x dx, which is equal to e to the x sine 2x the first term, minus the second term, 2e to the x cosine 2x. Okay, as you can notice, this integral part is now transposed on the left side, so you can now add c. And then what are you going to do is to add these two, so you will have 5 integral of e to the x sine 2x dx. So that's 4 plus 1, that becomes 5, equals e to the x sine 2x minus 2e to the x cosine 2x plus c. Again, so to avoid 5 on this side of the equation, you multiply everything by 1 over 5. So you have, we will go back to the original given, e to the x, sorry for that, that's e to the x sine 2x dx is equal to 1 over 5 e to the x sine 2x minus 2 over 5 e to the x cosine 2x, and then c times 1 over 5 is still constant c. So that's it, the integral of e to the x sine 2x dx. Now, if you wish to apply the tabular integration by parts, so you can still use it. However, on the last part of the method, okay, you still need to add the integral part of your integrals to the original given. So let's try the tabular integration by part for e to the x sine 2x dx. Again, you have your column u and then your column dv. So for your column u, say you let sine 2x be your u, and then your dv is e to the x. So for this purpose, we're just going to differentiate it only twice. So we have differentiating sine 2x, you have 2 cosine 2x dx, of course. So you only write 2 cosine 2x, and then you differentiate it again. So you will have negative 4 sine 2x, and then you may stop here, and then you start integrating e to the x. So you have e to the x and then e to the x. Okay, and then the distribution of sign will be plus minus. So we have the integral of, where will I write it? Sorry. So here, integral of the given e to the x sine 2x dx is equal to, then you do the slant multiplication. Okay, so we have, and then horizontally, so we have positive sine 2x times e to the x is e to the x sine 2x, and then negative 2 cosine 2x times e to the x is negative 2 cosine 2x times e to the x, negative 2 e to the x cosine 2x, and then minus, plus, minus, plus, and then plus, negative, then e to the x. So you just multiply these two, so you will have, I will just write it here, negative 4 integral of e to the x, then sine 2x. Sine 2x, and then you now affix the x. So what you notice is that the original given and then this integral part taken from the product of this horizontally are similar, sorry, and then you can just throw this on the other side, you combine it here, so you will have 5 integral of e to the x sine 2x dx, which is equal to e to the x sine 2x minus 2 e to the x cosine 2x, and then you can now add c. Okay, and then again, you need to remove this 5 by dividing each term here by 5. So you have 1 over 5 e to the x sine 2x minus 2 over 5 e to the x cosine 2x plus c, which gives the desired result as compared to the long method. Okay, so once more, that's 1 over 5 e to the x sine 2x minus 2 over 5, sorry, one more. That's 1 over 5 e to the x sine 2x minus 2 over 5 e to the x cosine 2x, and then plus c. Okay, let's have some more. Obviously, we do not have any direct formula for the integral of inverse trigonometric functions. So this time, we will generate, or we will obtain a direct formula for the integral of arc sine x dx. So here, you can just assume u be equal to arc sine x, and then dv is equal to dx. Let's get on. Say u equals arc sine of x, and then dv is dx. So we need to differentiate arc sine x. Again, you recall the derivative of inverse sine, that is equal to dx all over the square root of 1 minus x squared. And then you integrate this part, so you have v equals x. And then you have integral of arc sine of x dx is equal to uv, so that's x arc sine of x minus the integral of v du, so that is x dx all over the square root of 1 minus x squared. Okay, so as you can notice, this is integral of the form x dx all over the square root of 1 minus x squared. So from here, you can now let u be equal to 1 minus x squared, and you will notice that the derivative of u is negative 2x dx, and on the integrand, on the numerator, you only have x dx, so you need to avoid this negative 2 by multiplying negative 1/2 each term. So you have negative 1/2 du is positive x dx, and then you now have x arc sine of x minus negative 1/2 integral of x dx is your du all over the square root of 1 minus x squared is our u. And then you have x arc sine of x plus 1/2. Okay, that's plus 1/2. And then to integrate, you can just get the reciprocal of this. So you have u raised to negative 1/2 du. And then you apply the power formula. U to the n is u to the n plus 1 over n plus 1. Then you'll have x arc sine of x plus 1/2 times u negative 1/2 plus 1 is positive 1/2, and then over 1/2, or you just multiply by the reciprocal of 1/2, and then you can now add c. So finally, you have x arc sine of x, 1/2 times 2 is 1, and then square root of u, which will become 1 minus x squared, and then plus c. So in general, the integral of arc sine of x dx is equal to x arc sine x plus the square root of 1 minus x squared plus c. So technically, if you were given an integrand containing arc sine of x, then you may no longer use the integration by parts procedure, because we have already generated a direct formula for the integral of arc sine x dx. Okay, let's have some more. So in the case of ln x dx, again, there is no existing direct formula for the integral of ln x dx, and we try to generate it by applying the integration by parts procedure. Okay, so we let u be equal to ln x, and then dv, that's dv equals dx. So we differentiate u, so that gives us du, and then ln x, the derivative is dx over x, and then dv, the integral is v, and then dx, the integral is x. So we have integral of ln x dx equals uv, that's x, ln x, minus the integral of v du. When you multiply this two, you have x times dx over x. This can be cancelled out, so you only have dx. And finally, you have x ln x minus x plus c. So technically, so if you have integral of ln u du, then you can just say it's u ln u minus u plus c. Taking this as an example, so you have integral of ln 2x dx. We have, if we let u be equal to 2x, then du is 2 dx. So this is dx alone. So we have 1/2 du is equal to dx. So by change of variable, you can now have integral of ln u, then dx. Dx is 1/2 du equals 1/2. Then integral of ln u is u ln u minus u. U ln u minus u. Then you can now add c. Then that's 1/2 times u. U is 2x. Ln u, that's 2x. Minus 2x. Then plus c. And then the only thing left to do is to introduce 1/2 each term inside. So you have 1/2 times 2x is x. Ln 2x minus 1/2 times 2x is x, and then you can now add c. So that's it for now. That is the integration by parts procedure.